So today we are going to discuss on part 10.1 Lambda expressions and predicate. This will be the final video in OCA exam 1Z0-808 series. So before Java 8, if you wanted to pass behavior to a method like handling a button click or filtering a list, you had to use anonymous classes. These were long, they were verbose and hard to read. Java 8 introduced Lambda expressions as a much cleaner alternative. So a Lambda is simply a block of code that you can pass around and execute later, like a small inline method. Okay. So a Lambda has two parts. A left side is parameters and right side is body. Okay. Say you have parameters within first bracket, then arrow, and then within second bracket body. Okay. And there are some shortcuts. No parameters, that is first bracket empty. Then one parameter, parenthesis is optional, and single expression, no parenthesis and no return. Okay. Single expression, no double bracket and no return. Okay. So functional interfaces. So lambdas work only with functional interfaces. A functional interface has exactly one abstract method. The lambda provides the implementation of that method. The functional interface annotation is very optional, but it helps the compiler enforce this rule. So type interface, you usually don't need to write parameter types. The compiler figures them out automatically from the context. So here the key idea is that lambda is equal to short, a clean way to pass behavior instead of writing anonymous classes. The problem that lambda solve is, if you see the code here, so runnable r1 is equal to new runnable and then public void run and system.out.println hello. So before Java 8, whenever you wanted to pass a piece of behavior, something to execute later, you had to write an anonymous class. Look at how much code this is. So we are creating a nameless class, implementing an interface, writing a method signature, and then finally on line 4, writing the one line we actually care about, printing hello. 5 lines of boilerplate for code for one line of actual logic. Okay. But in lambda, what we write is that runnable r2 equal to first bracket, then arrow, then system.out.println, and then within quote hello. Right? This is exactly the same thing written as a lambda, one line. The empty parenthesis means no parameters. The arrow separates the parameters from the body, and system.out.println is the body, right? Println is the body, the one line we actually wanted to write. Everything else the compiler figures out on its own. It knows that R2 is a runnable. It knows runnable has a run method, and so it connects the lambda to that method automatically. Lambda syntax forms, we have to understand this, that first bracket and then arrow, system.out.println hi, right? There is no parameter. Then x, then arrow, x into 2, one parameter. Then x within first bracket, x comma y, then arrow, then x plus y, this is 2 parameters. Then x, then arrow, then with the second bracket, intr is equal to x into 2, then return r. So this is a block body. The pattern is always the same. Parameters on the left of the arrow and body on the right. And no parameters, you must write empty parentheses. Okay. So one parameter, parentheses are optional. You can write just x, and 2 or more parameters, parentheses are required. And if the body needs multiple statements, wrap it in curly braces and write an explicit return statement. Okay. So the functional interfaces, if you see this code, @functional interface greeting, then void say hello, right? And greeting g. So we have greeting g equal to first bracket, then arrow, then system.out.println hello. So g.say hello, and that is hello, and a lambda only works with a functional interface, an interface that has exactly one abstract method. The lambda provides the implementation of that one method. Here greeting has that one method, say hello. So the lambda, first bracket, then arrow, then system.out.println hello implements it. So when we call g.say hello, the lambda body executes and prints hello. The functional interface annotation is optional. It does not change behavior, right? So it just tells the compiler to enforce the one method rule. If someone accidentally adds a second abstract method to greeting, the compiler will flag it immediately. Okay. So if we look at this, so we can say confidently that a lambda is a short, clean way to implement a functional interface, an interface with exactly one abstract method without writing an anonymous class. So there are a few syntax rules the exam tests, so let us go through each one clearly. So for a single expression body, you write the expression directly with no braces and no return keyword. Java implicitly returns the value of the expression. For a block body, when you need multiple statements, you must use curly braces and you must write an explicit return statement. If you have braces but forget to return, it is a compiler error, right? Okay. So for parameters, one parameter can go with or without parentheses. 0 parameters must have empty parentheses and 2 or more parameters must have parentheses. Omitting them is a compile error. So the exam will show you various lambda syntax combinations and ask which one compiles, right? The two most common traps are missing return in a block body and missing parentheses with multiple parameters. Okay, so single expression body. So this is the simplest form. Okay, then x arrow x greater than 5. This is the simplest form. One parameter, one expression, no braces, no return keyword. Java evaluates the expression and implicitly returns the result. The whole thing is clean and readable in a single line. The rule is, if the entire body is a single expression, keep it very simple. No braces, no return. Then we have block body, right? X arrow and then within curly braces system.out.println, then braces checking plus x and return x greater than 5. When you need more than one statement, you switch to a block body. Curly braces wrapping multiple lines, but the moment you add braces, two things become mandatory. First, you must write an explicit return statement if the method returns a value. Second, the return must be inside the braces. Forgetting the return in a block body, it will lead to a compile time error. The compiler doesn't implicitly return anything when braces are present. You take on full responsibility for the return. Then we have one parameter and parenthesis is optional, right? So here we have x arrow, then x multiplication 2, then within braces x, then then arrow, then x into 2. Both are valid, okay? With exactly one parameter, you have a choice. You can write the parameter name directly with no parenthesis, or you can wrap it in parenthesis. Both compile, both run identically. The version with parenthesis is more common because it is shorter and cleaner. Multiple parameters is when parenthesis is required. Then you have within braces x comma y, then arrow x plus y, it's valid. But if you write x comma y and arrow x plus y without braces, then it will be compile error. With two or more parameters, parentheses are not optional, they are mandatory. The compiler needs the parentheses to know where the parameter list ends and the arrow begins. Without them, it cannot parse the expression and it will give a compiler error. Okay. And if you have 0 parameters, parentheses are always required. Here you have braces, then system, then arrow, then system.out.println high, right? So there is no parameter here. So you must write empty parentheses. There is nothing optional here. The empty parentheses tell the compiler explicitly that this lambda takes no arguments. So the complete parenthesis rule, if you see here, so we can say that 0 parameters, braces are required. 1 parameter, parenthesis optional. 2 or more parameters, braces are required. Okay. So and then there is another rule that single expression, no braces, no return, implicit return. Okay. And multiple statements, braces required, explicit return required. So these are the 4 combinations that are exactly what the exam tests. Okay. So now we are on predicate T functional interface, right? So predicate is the functional interface that the OCA specifically names in its official objective. It lives in java.util.function and must be imported. So predicate represents a condition, something you want to test. Its one abstract method is test, which takes an object of type T and returns a boolean. True means the condition is satisfied, false means it is not. So you create a predicate by assigning a lambda to it. The lambda takes one parameter and returns a boolean expression. Predicate within angle brackets integer is greater than 5 equal to x arrow, then x greater than 5. It creates a predicate that tests whether an integer is greater than 5, right? So to actually run this test, you have to call test with the value you want to evaluate. Is greater than 5 dot test within brace 3, it will return false. Is greater than 5 dot test, then within braces 10, it will return true. So predicate works with any type. Predicate angle brackets string lets you test string conditions. Okay, so predicate angle bracket integer lets you test numeric conditions. The type in the angle brackets is the type of the arguments test receives. Okay. Okay, so basic predicate on integer, predicate angle bracket integer is greater than 5 equal to x arrow x greater than 5. Then we have system.out.println is greater than 5 dot test braces 3, it is false. And then we have system.out.println is greater than 5 dot test 10, it is true, right? So we create a predicate of type integer. The lambda x arrow x greater than 5 is the condition. Is x greater than 5? Yes. And the is x greater than 5? The type integer in the angle brackets tells Java that the test will receive an integer. To actually run the condition, we call test and pass the value to evaluate, right? And test braces 3, is 3 greater than 5? No, false. So test within braces 10 is 10 greater than 5? Yes, it's true. The predicate itself is not a boolean. It is an object that holds a condition. You must call test braces to get the boolean result. Forgetting to call test and using the predicate directly is a compile time error. Okay. Then predicate on string, say we have predicate angle bracket string, then is long equal to s arrow s dot length braces greater than 5, and then we have system.out.println is long test hi, and system.out.println is long test hello world, right? So hi is false and hello world is true. Here predicate works with any type. Here the type is string, so test receives a string. The lambda checks whether the string's length is greater than 5, hi has length of 2, false, so hello world has length of 11, so it's true. Okay. So another predicate on string is that predicate string then starts with j, then s arrow, and then s dot starts with j, then system.out.println starts with j test java, then it's true, and system.out.println starts with j.test python, it's false, right? Same pattern, but it's different condition. The predicate tests whether the string starts with the letter j. Java does true, so it's true, and Python does not, it's false. So notice, you have to notice how readable this is, right? So the variable name starts with j, it tells you exactly what the predicate is, and the lambda body confirms it is it in one short expression. This is the whole point of predicate, named, that is reusable, readable conditions. Okay, so we have to see that the structure is always the same 3 steps here. Create a predicate with the type in angle brackets, assign a lambda that takes one parameter and returns a boolean expression. So and call test with the value to evaluate, right? So predicate angle bracket type, then name equal to parameter, then arrow boolean expression, and then name dot test value, right? So you have to understand one more thing is that predicate is in java.util.function. It must be imported. So it's one method is test, it returns boolean. Okay, the predicate object itself is not a boolean, so you must call test to get the result. Okay, so you have to remember this. So passing predicate to a method. Okay, so the real power of lambdas is that you can pass behavior to methods. A method that accepts a predicate as a parameter can apply any condition the caller provides without the method needing to know what the condition is. Okay, so passing predicate to a method. The real power of lambdas is that you can pass behavior to methods. A method that accepts a predicate as a parameter can apply any condition the caller provides without the method needing to know what the condition is. In printf, the method takes a string and a predicate string, okay? So inside it calls condition.test value, so which runs whatever lambda was passed in. The method itself does not care what the condition is. The caller decides, right? So you can pass a lambda directly as an argument, as arrow s dot starts with j, and without creating a variable. Java sees that printf expects a predicate string and a lambda with one string parameter, so returning boolean satisfied that. Okay, so if you can also store the lambda in a variable first and pass the variable. Both approaches are valid. So and negate is worth knowing for the exam. Negate method, it returns a new predicate that is the logical opposite of the original. So long word test for length greater than 4 and long word dot negate test for length length 4 or less. Okay, so let's get into the code now. So if we see static void printf string value predicate angle bracket string condition, if condition dot test dot value test value, then system dot out dot println value plus pass the test, else system dot out dot println value plus fail the test. So this is where the lambdas become genuinely useful. Printf takes two arguments, right? A string value and a predicate angle bracket string. So condition. Inside it calls condition.test value and then prints whether the value passed or failed. The method has no idea what the condition is. It does not care whether it is checking length or starting letter or anything else. The caller decides the condition. The method just applies it. This is the power of passing behavior as a parameter. The method is completely flexible. Okay, passing a lambda directly is printf java comma then as arrow then a starts with j passed. Printf python comma as then a starts with j, it fails, right? And we discussed this already. We pass the lambda as then arrow then a starts with j directly as a second argument. No variable, no intermediate step. Java sees that printf expects a predicate angle bracket string and a lambda with one string parameter. Returning boolean satisfies that perfectly. Okay. And so Java starts with j, it passed, and Python does not fail. So the same lambda, two different values and two different results. Okay. So storing the lambda in a variable first is that predicate angle bracket string. Then we have long word is equal to s arrow s dot length and then greater than 4, right? So if you have like we also discussed this one that printf hi then long word and printf hello long word. So hi will fail and hello will pass, right? Here we stored the lambda in a variable long word first and then pass the variable, and both approaches are completely valid and produce identical results. The variable approach is useful when you want to reuse the same predicate in multiple places without repeating the lambda expression. Hi is length of 2 not greater than 4, so it failed, and hello is length of 5 and greater than 4, so it passed. And then we have the negate method. It flips the condition. Okay, so we have predicate angle bracket string short word and long word dot negate, right? So we do printf hi short word, so it passes, and printf hello short word, it failed. What happens is that negate function, it returns a negate method, it returns a new predicate that is the logical opposite of the original. So negate method, it returns a new predicate that is the logical opposite of the original. Long word tests for length greater than 4, and short word which is long word negate tests for length 4 or less. So hi has length of 2, short word says true, passed, and hello has length of 5, short word says false, it failed. Exactly the opposite of what long word returned for the same values. Two things to notice here is that first negate returns a new predicate, long word itself is completely unchanged. Okay, and second we stored the negated predicate in a new variable short word. If we had just called long word dot negate without capturing the result, it would be discarded. Okay, same immutability pattern you have seen with string and date or time objects. So here we have to understand that a method that accepts accepts a predicate parameter can apply any condition the caller provides. Okay, the method stays general, the caller stays in control. Okay, the pass the lambda directly for a one-time condition or store it in a variable for reuse. Okay, and you can use negate to flip a condition without rewriting it. Okay, so now we come to the practice question. So let's trace the practice question step by step. Before that, answer is basically A, true, false, and false. So what happens is that we have static void check int value predicate angle bracket integer p and system.out.print then p.test value. Okay, so check takes an int and a predicate of integer. It calls test on a predicate with the value and prints the boolean result directly. Simple and clean. And then we have we have predicate integer. Then we have predicate integer is given equal to n, then greater than n mod 2, right? Equals 0. So in is even test whether a number is even. So n mod 2 gives the remainder when divided by 2. If the remainder is 0, the number is even, true, right? So remainder, if the remainder is 1, the number is odd, false, right? So we have check 4 comma is even, we pass 4 and is even. Inside check p.test 4 runs, then 4 mod 2 equals 0. So remainder is 0, condition is satisfied, test remains true, and it prints true, right? And then we have check 7 is even, we pass 7 and is even, we pass 7 and is even, p dot test 7 runs, so 7 mod 2 is equals 0, but remainder is 1 in this case, right, not 0. Condition is not satisfied, so test returns false, right, it printed false. Then we have check 4 is even negate, right. So now we pass the is even negate as predicate. Negate returns a new predicate that is logical opposite of is even. So instead of testing whether the number is even, it now tests whether the number is odd. So p dot test 4 runs on the negated predicate. 4 is even would return true, negate flips it to false, right, so it printed false. So is even itself is completely unchanged. Okay, so unchanged, negate returned a new predicate, so it did not modify even. So complete output is true, false and false. Okay, so if you want to practice such more questions, you can go to javalearn.plastamicro.com, and there are 1624 practice questions there, and you get timed exams and 29 full-length practice tests there. So this video concludes here. This full playlist concludes here. You'll find 30+ videos here, and wish you all the best.